The purpose of today's lesson, Special Right Triangles, is to explain to you why the rules exist for what are called 30, 60, 90 right triangles, which right here on your paper, your handout, you see the 30, 60, 90 triangle properties, and the 45, 45, 90, also known as the isosceles right triangle properties, why these two theorems are what they are. So what I'm going to do is I'm going to go back through, and I'm going to begin with a simple equilateral triangle. What is an equilateral triangle? Let me do this. Okay. So that outer triangle, let's make it a color. Okay. This yellow triangle on the outside is known as equilateral. All sides are congruent. Now, what's also true about the angles? They're congruent as well. And when you take the 180 degrees that makes a triangle and divide it equally 3 ways, what do you get? 60, 60, and 60. Now, what this picture has here is an altitude coming from the top angle down to the base. And that altitude is going to be what's called a perpendicular bisector. All right, so it cuts that base in half. So whatever the yellow sides were equal to, what's true about the green side? It's half of that. All right? Remember that. Now, the fact that it was a perpendicular bisector means that basically we have a 90-degree angle here, a 60-degree angle here, and then what does that bisector do to this angle up top? It also bisects it so that each angle is 30 degrees. So while the yellow triangle is an equilateral, what would you call this? A 30, 60, 90 right triangle. All right? What we're going to do today is explore the lengths of its sides. I'm going to begin by saying, what if this was 2 centimeters, feet, inches, whatever? What if that was 2? How big would the bottom green side be? 1. Because if this was 2, this would be 2, this would be 2, and this must be 1 because it's half, right? You cut that in half. That's no mystery, I hope. If you have a 30, 60, 90 right triangle, the hypotenuse is the longest side, is always going to be double the smallest side. You could write that down and cash it in at the bank. In a 30, 60, 90 right triangle, the hypotenuse is always double the smallest side. So if the bottom side was 11, what would the hypotenuse be? 22. If the bottom side was 110, the short leg we call it, what would the hypotenuse be? 220. What we do is we do what's called generalizing. Instead of using numbers, we're going to use letters. That's what it means in math to generalize. So instead of calling the bottom 1 or 22, 1 or 11 or 110, let's just call it A, and what must the hypotenuse be? 2A. That's a fact. The question is, how big is the other leg? If you know, great. We're going to assume we don't. We're going to find out why it is what it is. What is pretty much the most famous theorem in geometry, maybe all of math? The Pythagorean theorem, which basically says, it doesn't basically say, it says that in a right triangle, if this is A, B, C, how are they related? That might be the one thing that most people know or remember from math. Not sure why. A squared plus B squared is C squared. Maybe they know 1 plus 1. But they also, this is one of the things that people just seem to know. A squared plus B squared equals C squared. All right. So in this problem, what are we calling A? A. What are we calling C? 2A. And we're going to leave b as b. So instead of a squared plus b squared equals c squared, make it say a squared plus b squared equals the quantity 2a squared. What is the right side when you square the 2 and square the a? 4a squared. We're trying to figure out what b is equal to. So let's get that b squared by itself. Let's take away 1a squared from both sides. Look, I have 4a squareds. Oh no, I lost one of them. I have 3a squareds left. When you know what b squared is, how do you find b? You square root both sides. So b would equal, I'm going to write the plus or minus, but it's going to disappear, the square root of 3a squared. Why don't we need plus or minus when speaking of geometry, plane geometry? Correct. We can't have a negative length. Now, when you get into trigonometry and pre-calculus, you will talk about positive and negative lengths, but it refers to what direction the side is in. If it's above the x-axis, you might call it positive, below the x-axis, negative. To the right of the y-axis will be positive, to the left of the y-axis will be negative. But for now, let's leave out the plus minus just to simplify things. So b is equal to the square root of 3a squared. That's not what I'm going to write in this diagram. What am I going to write? Can you square root 3 nicely without a calculator, without decimals? Then leave it as a root 3. Can you square root a squared? It's a. So b is equal to a times the square root of 3. That's the length. A root 3. When you have a 30, 60, 90, which we have here, right? We have a 60, 30, 90. The smallest leg is called A. The hypotenuse is double A. And the longer leg, the medium side, this would be small, medium, large. The medium side is going to be A root 3.